In this video, we're going to focus on solving equations with variables on both sides. By the end of this lesson, you should be able to solve equations with variables on each side. You should be able to use the distributive property to solve equations, and you should be able to combine like terms while you're solving equations. Remember that like terms, we talked about this yesterday, but like terms are terms that have the same variable raised to the same power and are on the same side of the equal sign. So 2x and x are considered to be like terms because they are on the same side of the equal sign, so you can combine them. 2x and x, although they have the same variable and they're on the same power, you can't combine them because they're on different sides of the equal sign. So what you would have to do here is what is known as the property of equality. And so this is where you add or subtract by the same thing on both sides so that you can move them to the same side. Okay, our steps for solving multi-step equations are as follows. You're going to first distribute if necessary. So if there's a distribution that needs to take place, you do that first. Then you can combine like terms. Again, this is if necessary. So if you end up with like terms, or you have like terms, then combine them, and then you can begin the process of solving the equation. So you would add or subtract first. You're moving all of your constants on one side. You're going to move all of your variables on the other side, and then you're going to begin to multiply or divide so that the coefficient in front of the variable that you're looking for becomes 1. And then you're going to reverse PEMDAS. So you're undoing PEMDAS. So in PEMDAS, you do parentheses, exponents, multiplication, division, and then addition and subtraction. Here you're doing the reverse of that. So we start with adding and subtracting first, then multiplication and division. Then if we have exponents, we take care of those exponents, and then we start moving things outside of the parentheses. When we're solving equations, we sometimes get equations that have no solution. This is when your solution ends in a false statement. So what I mean by this is that you're solving the equation, such as our one that we have here. This 2n minus 4 equals 2n plus 6. And as you start solving things, as we move our variables to one side, we see that they cancel out. And what we're left with is negative 4 equals 6. Well, at this point, you really can't do anything with that. And we know that negative 4 does not, in fact, equal 6. So what we end up with is a false statement. When this happens, we have the answer is no solution, or it's the empty set. There's nothing that, there's no solution that will work for that. So we said there are no things in this set that will work for this particular equation. So this is when the solution ends in a false statement. This is what we call a no solution. And then other times we have where the equation has more than one solution, or infinitely many solutions, or all real numbers would be the solution. So this is going to be the same thing that we just saw on the previous slide, but this time when you solve it, what you end up with is a true statement. So the variables will cancel out, or the constants will cancel out, and you'll be left with the same thing on both sides. When this happens, this tells us that any value that you put in for m, or for the variable, will work. And so we would say all numbers, or all real numbers, would be considered solutions to this problem because any number will work. Okay. Remember that when we are solving equations, that typically we're having to also write them from word problems. So think about some words that would indicate different operations that might be happening here. So for addition, you might see add, increase, more than, sum, total. For subtraction, you might say take away, or decrease, or reduce, or to decline, okay, or descend. For division, you might see words like split up, or allocate, or separate, or divide, or quotient. And for multiplication, you might see words like times, or multiply, factor, product, to enlarge, to magnify. These are all words that if you're reading through a word problem, that would give you indications of the operation that needs to be done here. Let's practice with a couple of examples. So here we have our first example. We have m minus 5m plus 3 equals 47. So remember, our steps are to distribute, if necessary, combine like terms, and then we can start moving things around. So we don't need to distribute on this one because there's no parentheses, but we do have like terms that we do need to combine. It's this m and this 5m. We know that they're like terms because they're on the same side of the equal sign. They have the same variable, same power. So m minus 5m, remember that you're including the operation that comes in front, combined to give us negative 4m plus 3 equals 47. Okay, so now we can begin solving this equation. When we're solving the equation, our goal is to get all of our constants on one side and all of our variables on the other. Since this is the only variable that we have here, this means that I'm going to want to move this plus 3 to the other side with my other constant. So we're doing this property of equality here. So if I want to move a 3 to the other side, I do the opposite operation. So I do the opposite of addition, which would be subtraction, and I do it to both sides. What we're forming here is our zero pair, and what we're left with on this side is the 4m, and what we now have on this side is 47 minus 3, which is 44. Now, when we're solving equations, I'm looking for the value of m, not the value of negative 4m, and so I need to divide by this coefficient here so that I get rid of the negative 4, and then I'm just left with m. So again, we're multiplying by 4. To undo multiplication, we would divide, and we do it on both sides to keep it equal. The negative 4's here go away, and 4 divided by negative 4 would be negative 11. So our value here for our equation is m is equal to negative 11. Okay, let's look at another one. We're not going to do all of these examples that are on here, but let's look at C. If we have 7 minus 3r equals r minus 4 times 2 plus r. So remember that we are combining like terms, or we're distributing first. So that's our first step, is to distribute if necessary. So if we look at this top, if we look at C, we see that there are parentheses here. So I do need to distribute. So I'm distributing this minus 4. It's very important that you recognize that across. So we have r, and then minus 4 times 2 plus r. So this will be r. Negative 4 times 2 is negative 8. Negative 4 times r is minus 4r. And then equals, on this side, 7 minus 3r. Remember that after the distributive property, you're going to combine like terms. Remember, like terms, same variable, same power, and on the same side of the equal sign. So I can't combine the 3r because it's on a different side, but I can combine the r and the minus 4r. So when we combine that, we're going to be left with negative 3r minus 8, and then is equal to 7 minus 3r. Alright, so if we're looking at this one, 7 minus 3r is equal to negative 3r minus 8. We're solving the equation. Okay, we're getting variables on one side, we're going to get constants to the other. So let's start with variables. Let's make sure that our variables are on the same side. I like to move the smaller of the two variables. In this case, they're the same, so it doesn't matter which one I move. I'm going to just move this one. Remember that if we're moving something, we do the opposite operation. So if I have negative 3r, the opposite of a negative would be plus or positive. And I'm adding it to both sides. The 3r's here form zero pairs. The 3r's here also form a zero pair. And so what we're left with is 7 on this side, negative 8 on this side. What we can now see here is that this is a false statement, because I don't have the same thing on both sides. We know that 7 does not equal negative 8. So because this is a false statement, this would be a no solution. So this would be a no solution. Okay? If we're looking at the bottom one, we would end up with the same thing, but we would have the same thing on both sides. We would have negative 7 left on both sides, and so this would be a true statement. All right, we want to solve each equation. So what do we do when we have division in our equation? Okay, well, A and B both have division, but each one is expressed a little bit differently. So let's look at this. So here, because the division is not over both, we're going to focus on getting rid of this 15 first, and then we'll take care of division. Remember, we're doing reverse PEMDAS. So we take care of addition and subtraction first. So we're going to get rid of this 15. We're going to move it to the other side. To move it, we subtract it from both sides. So subtract, that's gone. Subtract it here. 8 minus 15 gives you negative 7 equals C divided by negative 3. So now that we've undone the addition that was there, we can now begin to undo the division. To undo division, remember that the opposite of division would be to multiply by negative 3. The inverse would be to multiply by negative 3. And if we're doing it on one side, we need to do it to the other. The negative 3's here will cancel each other out. And negative 3 times negative 7 gives us negative, or gives us positive. Because remember that negative times a negative is a positive. Gives us positive 21. So we have 21 is equal to C. B is a little bit different because we have, because it's all together underneath, above the 2. What this is saying is that we have 3a minus 1 grouped in parentheses, and all of that's being divided by 2. So remember that in this case, we're doing reverse PEMDAS. We don't have any outside addition and subtraction because it's inside parentheses, so we're skipping that step, and we're moving to multiplication and division before we can move to parentheses. So we're going to have to get rid of this dividing by 2 first. So inverse of dividing by 2 would be to multiply by 2. We do this on both sides. The 2's here cancel each other out, so we're left with 3a minus 1 is equal to 2 times 4, which is 8. And now we can begin to solve this equation. So now we're going to move the 1 by adding it to both sides. We'll have 3a is equal to 9. And then dividing both sides by 3 gives us a is equal to 3. We want to write an equation and we want to solve. Remember that you're looking for these words. So we have 2 times. This tells us to multiply. The sum, this tells us that there's going to be addition in here, of x and a number is the same as, here's our equal sign right here, is the same as 5 less than, so this tells us subtraction, 3 times x. So this tells us that we're going to be multiplying here. So in our equation here, we have 2 times the sum. So 2 times the sum. So it's saying we're taking the sum and we're going to multiply by 2. Well, the sum of what? The sum of x and 2. So we're going to take the sum of x and 2 and we're going to multiply it by 2. And then we know that this is equal to, is the same as 5 less than. Okay, so we're going to take 5 less than whatever comes after it. So what comes after the less than? So 3 times x. Anytime we have this less than, don't get it confused with less. If it said 5 less 3x, then you would do 5 minus 3x. But because it says less than, what that's actually telling you is to take everything that comes after the less than part first, and then take away the 5. Here we have Mandy bought a DVD player. The sales clerk says that if she pays $80 now, her monthly payments will be $32, and the total cost will be $400. We want to write an equation and we want to solve to find how many months she will have to make payments. So we know that the total cost is $400, and we know that if she pays $80 now, so she makes an initial amount of $80, her payments will be $32 a month. So the number of months would be x. The total cost would be the $400. So if we know that the $32 a month plus 80 should give you the total cost of $400. Okay, before watching the next video, please consider the following prompt. An equation has infinite solutions when? So how do we know when an equation has infinitely many solutions? As usual, please subscribe to the channel so that you get updates on when new videos are posted.